All right, everyone. Happy Friday. Second day of remote learning. Didn't think it would happen, did you? So we are going to go over a lesson today. We do have to do a full lesson, so we're doing 725 today. I do need you to take notes. Notes are going to be essential for your grade. I will not accept the homework if you do not have the notes. Now, it is important that you note that you do have a handout. So please make sure you pause the video, get that handout because we're going to be using it during class. If you also have a calculator, that would be very helpful. So please get a calculator. Otherwise, you can always use a calculator on your Chromebook. Okay. We are going to be doing a couple problems, and I do expect you to do them. So I will have you watch the video, then pause at a certain point, and then unpause when it's time to do the rest of the work. Okay. So you'll pause the video, do the work, unpause, continue. Watch the whole video. All right. I do need you to watch the whole video and take notes on the whole video, and then submit both the video or both the homework, this homework right here, 81 through 86, and the notes. And you do have until Monday night at midnight to get that turned in since we have the really long weekend, okay? So no complaining about not having enough time. You have enough time. Make sure you make it happen, okay? All right, so again, have your handout, have a paper, have your calculator as we go over this. And also have your homework because we're actually going to go over the homework. Although, I guess, did we already do this one, 724? I don't remember. If we haven't checked it off the top of my head, I can't recall. No, actually, we're supposed to do it yesterday. So, yes, please check your homework. Here it is. Pause the video when you're done, unpause it, and come back to it, and we'll do the next part. Okay, so here we go. Let's go to the next part. Here's what I want you to do on your paper, on your line paper. Please start out with this. I do want you to pause the video and label as many of these as we can. We have added some new ones to this list, so you should be able to add quite a few. By the way, this may very well be a quiz at some point next week, so please make sure you know these. All right, so pause the video and put as many of these labels as you can. Go. Okay, hopefully you paused it, hopefully you did it. This is a great test right now to see how many of these you remember. I'm hoping you have at least two for each one of them. For M and B, you should now have quite a few. So here are the ones you should have. Holy cow, that's a lot of them. So please pause the video now and write down in a red pen whichever ones you did not have. Got it? Go. Okay, so you should be good to go now. You should have these written down. By the way, you will notice these right here, change in y over change in x, vertical change over horizontal change in rise over run. You might be like, they're the same thing. Well, pretty much they are, but sometimes one is going to be more helpful than the other. And we're going to focus on that today. Now, of course, you should know slope from now on. That is one that we always need to know. So the main ones, again, are dependent variable, circle it. Slope, circle it. Independent variable, circle it, and y-intercept. Those are now the four official names. Those are the main ones I want you to know. Please make sure you remember them. Today we're going to add one more to this m. So here we go. All right, 725. How can I connect rates to slopes? Proportional equations. So we've been doing some work with just regular graphing linear, but now we're going to focus on proportional. Now, before we get too far, can you please tell me what two things must be true for a relationship to be proportional? And if you don't have it, write it down. Proportional relationships. Number one, okay, grow by constant amount. Okay, it has to grow by a constant amount at every point. And number two, which of course, by the way, if it grows by a constant amount, means it is linear. But the big thing about a proportional relationship, it must go through the origin. And what is it? What's the origin? The origin is 0.00. So it must go through 0.00. So please make sure you have that. Write it down. Smile. Yay. Okay, 0.00. All right. In chapter 1, you identify proportional relationships in both tables and graphs. Today we'll look at the connection between slope and graphs of a proportional relationship. Political poll. You know what? Politics never get away from them. Mr. Mears was running for mayor of Atlanta. His campaign managers were eager to determine how many citizens of Atlanta would vote for him in the upcoming election. they decided to pay a respected, impartial statistical company to survey potential voters, a process called polling, to find out how many people would probably vote for Mr. Mears. By the way, this happens every single time there's an election, okay? You've heard about it. They say, hey, at the polls, this is what they found out. What they mean is they call people and they find out, or they ask people and they find out, okay, how many people would vote for it. Okay, so like, for example, they would do this right here. One afternoon, pollsters called 100 random potential voters in Atlanta to ask them how they would vote in the election. During the survey, 68 people indicated that they would vote for Mr. Mears. Okay, if the pollsters instead called 50 random selected potential voters, predict how many of them would have said they would vote for Mr. Mears. By the way, you should write on your paper 777. Should say 725 at the top of your line paper. Okay. So here we go. If 100 people were voted or were called and 68 said they would vote for him, how many would vote for him if 50? Well, go ahead and do the work. When you're done, unpause it and we'll check. All right, so hopefully you saw that we're talking about proportional relationships. A proportion is when we have two ratios equal to each other. So if 100 people were asked, 100 voters, and 68 vote for Mr. Mears, I'm going to put an M for Mears, okay? We'd write it that way. Then when 50 other people were called, would that go on top or on the bottom? It would go on the top, 50 voters. And so then we were trying to find out X. And we can do that a bunch of different ways, but ideally the best way you do it is, again, the thing we talked about. Actually, you know what? Let me rephrase that. Some of you might be like, well, I'm just going to multiply the diagonals, multiply these and divide by that. Why would you do that? Why wouldn't we not just go here and say, hey, divided that by 2? So if I cut this in half, I get 34. So 34 people would vote for Mr. Mears. Okay? Make sure you write that down. 34 people would vote for Mr. Mears. And a proportion is the best way to go that. Do you suppose that this relationship is proportional? Why or why not? Well, did it go by a constant amount? Are they assuming that out of every 50 people or every 100 people, 68 people will vote for Mr. Mears? Yeah, that's the assumption. So it is going at a constant rate. Would it go through the origin? Would it go through 0.00? Yeah, you probably would, because you wouldn't expect 0 voters to vote for if 0 people vote, 0 people are going to vote for Mr. Mears. So is it proportional? Yes. Okay. Why? Because we assume it grows at a constant rate. Write this down. I'm going to be looking for this in your notes. And constant rate and goes through the origin. Okay? Goes through the origin. Sorry, I'm writing not too great. I did come to school, believe it or not. I'm actually at school. It is now midnight, so I'm technically doing it right on Friday. Okay, for me, it's easier to come to school and make these videos here at school. So I'm here to make this video for you, so hopefully you're watching it. Okay, if you haven't copied that down, pause it. Otherwise, I'm moving on. All right, Karina's neighborhood has 327 potential voters. If voting in her neighborhood is similar to that of the poll, how many neighbors will probably vote for Mr. Mears? Complete the table below. So do whatever you need to do. Find that missing value. Go. When you're done, unpause the video and we'll check it. All right, so you could have done it a bunch of different ways. I'm going to go ahead and keep going with my ratio of 100 voters and 68 vote for Mr. Mears, and then put that equal to 327 voters over X. And when I solve that, in this case, I'm definitely going to do the multiply the diagonals and divide by the third value. Okay, that's a definite, would make my whole life a whole lot easier there. And when I do that, I do get decimal, right? Not an exact number. I get 222.36 or roughly 3,600. So in this case, I'm going to round to the nearest whole number and say 222 voters. In that case, it would make sense because we don't want to just put the decimals there. Next, here's where the work comes and here's where your handout comes into play. Make a graph of the data Karina has collected and draw a line through the point. Even though, again, it should be discrete, we do want to go ahead and connect the points and make it continuous just so we can see it better. Should the line go through the origin? How do you know? Okay, so on your paper or on your handout, you should have this right here. Please go ahead and turn to it, pause the video, make the graph, draw a line through it, and then see if it goes through 0.00, why or why not. Go. All right, you paused it, you did it. Okay, let's check. Your graph. Ooh, did you do it well? I'm hoping it looks just like this. That's what your graph should look like. Ooh, hold on. Forgot the arrow there. Okay, you should have a title. Oh man, I forgot a couple other things. Arrows there, arrow here. This is Y, this is X. You should have labels down at the bottom, labels on the left side. And again, we ask to connect the points. And here it is, all right? Now, letter E says, what is the equation of the line in the y equals mx plus b form? Okay, here's what I want you to think about. I want you to think about this, and as you're looking at this, you're like, man, it just kind of goes through lattice points, but Mr. Ramirez, you didn't draw that line very straight. It doesn't look straight. You're right. So how am I going to be able to find the point or the growth, the slope, okay, m? Well, one way to do it is to use the points we know. We know that at 50, okay, 50, we would be at 34. So this point right here, the coordinate point here is 50, 34, right? That means it rose 34 and it ran 50, right? And it does it again. It runs another 50 and then rises another 34 and runs another 50, okay? And then rises another 34. And it's going to do that on a regular basis. So if I know that, if I know my rise is 34 and my run is 50, the cool thing is, there is my slope. So my slope in this case, y equals rise over run, 34 over 50, x plus, b is my y-intercept. What is my y-intercept in this proportional relationship? It is 0, so plus 0. So do I actually need to write it? No, not really. I could just go with that. This is my equation in y equals mx plus b form. By the way, ugly decimal or ugly fraction, but I love it. I love fractions as a slope because it tells you your rise and it tells you your run immediately there. So do not run away from fractions. Go with it, okay? Use those to your advantage, okay? All right, use the equation to help Karina figure out how many people would probably vote for Mr. Mears. If 350,125 people vote in the election, what do X and Y represent in the equation? And again, by the way, people do this. They really do. They pay for people to poll people to try to figure out how many people are going to vote in the election. Okay? So I'm going to use my equation. It was Y equals 34 over 50. You also could have used a 68 over 100, X. Okay? And in this case, wait, which one is what? Which one would be 350,125 people? That would be your X. So I'm going to replace that X with this number, 350,125, and solve it there. Now, guys, I know in calculator, how do I do 34 over 50? Or 68 over 100, since it's the same thing? You can always divide it. And if you divide it, you get 68 hundredths times 350,125. And your answer then would be, what would you get? Would you get? Did you do it? Would be 238,085 voters or votes. Okay, that's what they would expect to be able to get there, okay? By the way, please don't forget the second part of the question. In this case, we do need to say what X and Y represent. So in this case, X is a number of potential voters, and Y is a number of total expected votes for Mr. Mears. Okay? Now, what information would the unit rate give Karina? What is the unit rate? How does the unit rate compare to the slope? Now, again, unit rate is referring to how much for one. Okay, how much for one? Every one person, okay? Every one potential voter. So in this case, and again, my denominator is usually going to be on the bottom. So one voter, how many would we expect to vote for Mr. Mears? Well, we have 34, but if I simplify it, if I go 34 over 50 or 68 over 100, both of those are equivalent, right? And they're both the fractions we could use here for this, the rates, but I want to change it to the denominator of 1, I would divide 34 by 50 and I would get my 6800s. Okay? 6800s over 1, these are the votes, over one voter. So every one voter would expect to give me 6800s. Now I know that doesn't make sense as far as a partial vote, but this is just finding the average. And then it says, how does that connect to my slope? Well, guess what? This unit rate right here, every one gives me a unit rate, that is my slope. Okay, so your constant of proportionality, the constant in which you're growing by, is your slope in this situation. Okay? All right, 778. In 2 minutes, Stacy can write her name 17 times. 2 minutes. Use a proportion to find how long it will take Stacy to write her name 85 times. Go. Pause it. When you're done, unpause it. Okay, should have done 2 over 17 equals x over 85. And when you solve that, you would get x equals 10 minutes. So in 10 minutes, she would be able to write her name that many times. Well, letter B, go ahead and graph it. So we're going to go right here again. We're going to graph it. Think about what goes on the x-axis, which goes on the y-axis. Graph it. Make it perfect. Do go ahead and connect the points as well, just like we did last time, even though technically it should be discrete. But just go ahead and continue and make it continuous, and we'll go from there. When you're done, unpause. All right, so here's what the graph should look like, and I expect to see this on your notes. There it is. Again, please make sure you got your labels, your title, connected the points, got all this information there, right? Okay, excellent. So now, question B says, or question C, I'm sorry, looks like this. Another name for the slope in a proportional relationship, if it's proportional, guys, it has to be proportional, is the constant of proportionality. I know it sounds really fancy, but it's just finding the slope. Find the constant of proportionality and write the equation in y equals mx plus b form. For Stacy's situation, what do x and y represent? Again, the nice thing is x and y, we know x, we just come back here and see what was on my x-axis. It's the number of minutes, right? X is number of minutes, Y is number of signatures. Okay, and now I'm going to go Y equals mx plus b. Y stays the same. I need to find my slope. I need to find my constant of proportionality. So think about it. Every time I go over 2, I go up how many? I go up 17. So every time I go over 2, I go up 17, just like it said right here. Oh, like I said right here. That she goes 2 minutes and 17 times. So the constant of proportionality is saying, how far does she go in 1 minute? So how much is this? Where is that exact number? Now, you might be like, I don't know, I can't quite tell because it looks over here like it's 8 or 9 or something like that. But if I know it's 17, okay, every 1 minute, how much is she going to go if she goes 17 in 2 minutes? So I'm going to go ahead and divide that, all right? And when I divide that, I get 8.5. So this right here, in 1 minute, she goes 8.5. That is my constant of proportionality. So over here, 8.5 over 1. You don't have to put over 1 if you don't want to, but you can. And then my y-intercept, well, it's a constant proportion or a proportional relationship, so it goes to the origin. So plus 0, which I could or wouldn't have to write. Okay. And now please use that equation to find how long it would take her to write her name 85 times. When you're done, unpause the video. All right, so you use your equation. Y equals 8.5 x. All right, and in this case, that is talking about 85 times. How long would it take? So what is x? What is y talking about in this situation? In this situation, the x is talking about the number of times Stacy writes her name, or I'm sorry, the y is. So this is going to be 85 equals 8.5 times x. And so there, I go ahead and solve it now. And the question would be, okay, what would I do here to find this? Okay, so in this case then, I would go ahead and divide both sides by 8.5 by 8.5, and I get 10 equals x. So it would take her 10 minutes to sign her name 85 times. What's the advantage of using the equation compared to the proportion? Is there an advantage? Do you feel it's easier to use an equation, or is it better to use a proportion? Okay. I want you to take a second and write down what you think. What's the advantage of a proportion? What's the advantage of an equation? Go. All right. Some of the things you might have had. You might have said a proportion. Hey, it's a nice, easy way to solve it. You feel comfortable. You've done it for many, many times. So there is some advantages to using a proportion, and you might like it better. Okay. Another one. Well, an advantage of an equation might be that you can plug in any value into the equation and solve it immediately. Okay. You also know the unit rate immediately when you have an equation, because you just look at the slope and you can build off that. Then the last thing is find the unit rate for Stacy, how she writes her name. And we already kind of did that, right? Okay, we said if she writes her name 17 times in 2 minutes, how many times would she write her name in 1 minute? Well, probably you can use a scale factor, divide by 2, and I get 8.5. So that is my unit rate, 8.5 names in 1 minute. All right, I got one last problem. We're going to do one more. Problem 780. 8 of 29 students in your class want to attend the Winter Bowl. Find the constant of proportionality and then write the equation in y equals mx plus b form. What do x and y represent? Go. Pause the video. When you're done, unpause it. All right, so if you went with this, you would have said 8 students, okay? 8 want to go to dance out of 29 total students. All right, so if we're looking to find the constant of proportionality, we need to find the unit rate in this situation. So if 8 want to go to the dance out of 29, how many want to go total? Well, you might want to say, well, 8 over 29, that doesn't simplify to anything. And what would I do? Guys, this right here is your constant of proportionality, 8 and 29. So 8 out of every 29 students are going to go. So my equation, y equals 8 out of 29, x. All right? Well, what do these numbers mean then? X is a total number of students. X equals, actually it should be total number. Write this down. Make sure you have this. X is total number of students. Y is number who want to go to the Winter Bowl. And if your class represents the entire school, how many of 1,490 students will probably attend the dance? Solve your equation for part B. So please use this equation right here and solve it. Go. All right, when I do that, I should have gotten this, 8 over 29 times 1,490, which would give me approximately, feel free to use the approximate symbol here, approximately 411 students, which is my solution. All right, guys, that is what we're doing for today. Again, it's kind of weird. I know it seems a little silly, but it just says if you can find the rise and the run, this is always going to be your rise and your run. That also is your fraction, okay? So when you're thinking of a proportion and the constant of proportionality, they already give you the numbers. 8 out of 29 students, that is your fraction. That is going to be your slope. So another reason why fractions are really good in our work here with slopes, okay? In your book, I'm sorry I don't have it, in your book you do have another math notes box that talks about proportional equations. You're welcome to check it out. If you have any questions, you can go there. I'm expecting to see these notes and your 2 graphs completed when you submit your homework. Again, you must have that completed in order to get credit, so please make sure you have all of that taken care of, okay? All right, that is it for today. Make sure you get that homework in. Have a wonderful long weekend, and I hope you stay out of trouble and do some shoveling, okay? Although I guess it's supposed to be nice and warm over the like Monday, so we'll see. All right, I'll see you later.